Now for example 3, we want to write each sum using sigma notation. So what we have here is we have an expanded sum that we want to shrink down and write using sigma notation here. So we have 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus dot 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 plus 1 over 10 squared. So hopefully you can find the patterns and those things that change and those things that do not change. So looking at this, all of them have a 1 on top. So our function is going to be 1 divided by, and then what's changing is right down here. And what doesn't change here is the squared in every case. So I'm just going to call this k squared. So there's our function. Now we need to write our summation notation. So we write our sigma. Okay, probably take a little bit of practice to get that down. And k here is going to be our index of summation. It's the thing that's changing. And looking at this, we're going to start it right here at 1. So k starts at 1. And then where does k stop? Well, right here at 10. And so this is going to be 10. So we read this as the sum as k goes from 1 to 10 of 1 over k squared. Alright, for our next one, sometimes it's not always so cut and dry here where we had 1, 2, 3, so on and so forth. It was just very perfect. This example, it's a little less obvious of what's going on here. So what we want to do is find the pattern going on with this series of numbers. And what I can see is that this is increasing by 2 every time. Now when you have a function that increases by 2 every time, it's going to be 2 times some value. And let's just use j for that value. Why not? So our index of summation can be pretty much any letter. We're going to let it be j. Now what we have to think about is how do we get the function 2j to equal these values? Well, if I did 2 times 1, that would give me 2. If I did 2 times 2, that would give me 4. If I did 2 times 3, that would give me 6. Now notice here I want 1, 3, 5. This, however, gave me 2, 4, 6. And so hopefully you can see that if we subtracted 1 from each of these, we would get our 1, 3, 5. So our function is actually 2j minus 1. Okay? Now, if we looked at our summation, okay, what did we let j be at the beginning here? Well, we let j equal 1. So using this function, we would let j equal 1. And what would j go up to? That would give us 99. So we kind of have to think, this would be, what, 2 times 50 minus 1. So this would be 100 minus 1. So that means j needs to go all the way up to 50. And this would be a way of writing this in sigma notation. Now there is multiple answers that we could put here. Okay, so let's just say that j started at 0. How would that change our function? Well, we still are going up by 2 every time, so that would give us some sort of 2j. But now if we plug 0 in for j, that would give me 0 to start off with, and I want to start off with 1. So in this case, I would have to add 1 to get to my series. Okay, so what would be the ending index if we had the function 2j plus 1? Well, we want to get to 99, so 2 times what plus 1 equals 99? Well, this would have to be 2 times 49, because that would give me 98 plus 1 to 99. So 2 different ways writing the same sum with sigma notation. Alright, I want you to try letters C and D on your own. See if you can come up with the summation notation for these two series, and Pause the video, then come on back to check your work. Alright, welcome back. In letter C, you have to notice that this pattern is a series of squares, and it actually starts with 4 squared, then 5 squared, 6 squared, and goes all the way up to 10 squared. So my pattern goes from 4 to 10 of I squared. In letter D, our ending point kind of gives you the function that we're looking for, right? It's right here at the end. So I just replaced n with another letter like k, and k plus 1 squared over n. Now the trick is finding where does it start. And so this has to fit into our function of k plus 1 squared over n. So what I did is I set k plus 1 squared equal to 100 and found that k had to equal 9. So 9 was going to give us our starting point, and then it goes up until n right there. And so our ending index is n. All right, let's move on.